Hello everyone. This video will show how to determine the missing y coordinate of one of the vertices of a triangle using the determinant of a matrix. Now let's go over this example. So we're given a triangle with vertices A, B, and C, and we can see that our vertex C has a missing y value. And the area of this triangle is 12. So I'm going to go ahead and plot these two vertices A and B up here. It says here that our vertex C has an x-coordinate of 3, so it should be sitting within this line right here. I'm going to go ahead and write the formula to find the area of a triangle using determinant of a matrix down here. This notation tells us that the area of a triangle using the determinant of the matrix is equal to 1/2 of the absolute value of the determinant of the matrix formed from the vertices of this triangle. So in this case right here, this will serve as our x sub 1, y sub 1, x sub 2, y sub 2, and x sub 3, y sub 3. And notice that the third column will all be 1. So I'm going to go ahead and plug in the values that we know from here. So we know that our area is 12. So I'm going to write 12 up here. And that is equal to 1/2 of, we're going to write down the coordinates of the vertices of the triangle. So that we can get rid of this 1/2, we can multiply both sides by 2. So this becomes 24. To find the determinant of this matrix, we're going to go ahead and write the elements of the first row. We remember that we're going to have an alternate plus, minus, plus, minus. So we already have written the elements of the first row, so we're going to cover it. And we're going to write the 2 by 2 matrix that will be multiplied to each of these elements here. For the first one, for -3, we're going to cover the first column, and whatever's the left over, that's the 2 by 2 matrix that we multiply to the first one. And then for the second value that we have right here, we're going to cover the middle, and the left over will be the 2 by 2 matrix that we will multiply to this. And for the third value that we have here, we cover the third column. So we go ahead and simplify this. We got a 24 equals the absolute value of negative times positive is a negative. And then we are going to multiply the diagonal for this. 1 times 1 is 1 minus. And then we will multiply the anti-diagonal. That is 1 times y is y. And then we have a minus 1. We're supposed to have a -3 right here in front of these parentheses. And then we're going to multiply again the diagonal. 5 times 1 is 5. Minus 1 times 3 is 3. Plus 1 times 5 times y is 5y. Minus 1 times 3 is 3. So we go ahead and simplify this further. So we can distribute this. This will come out -3 plus 3y minus, that's 5 plus 3, because we're distributing the -1 to each of the terms. And then we're going to distribute this 1 to each of the terms there. So that would be plus 5y minus 3. And that's an absolute value. So we go ahead and combine like terms. So we start with the y. So we get a positive 3y plus 5y is a positive 8y. And then we're going to add the constants. We get a -3 minus 5 plus 3 minus 3 is a -8. Since this is absolute value, we're going to have 2 equations for this. So we can go ahead and solve for y from here. We're going to start with the first equation. So our first value for y is 4. This tells us that the coordinate for vertex C would be 3 and gonna be 4. So this is where Vertex C is going to sit 3 and 4. So this red triangle right here will have an area of 12. Now we're going to use the other equation to find for the other value for y. So the other coordinate for C is located at 3, -2. Notice that these two triangles, the red and the blue, will both have an area of 12. So that is how we find the missing coordinate of one of the vertices of a triangle using the determinant of a matrix.